Okay, today we're going to start talking about inverses. Hopefully you remember this from Algebra 2. Inverses undo each other. The x and the y switch when finding the inverses. And the domain and the range also switch. Inverses are a reflection over y equals x, so you can kind of see if you've done it right on the graph. If when you think about y equals x, start at 0 and a slope of positive 1, would it fold over on that line? The inverse of every function is not necessarily a function. The original function must pass the horizontal line test and be one-to-one in order for the inverse to be a function. So you can kind of see if you've got a graph, if it's going to be a function or not by, just like the vertical test, the vertical line test, it passes the horizontal line test. We can restrict the domain of a function so the inverse will be a function, which I'll show you what that means. That's when I take the inverse of a square root, for example, and when I turn that into its inverse, I get a quadratic. Quadratic is a full U, and the inverse of a square root would just be half of that. And then when f of g of x and g of f of x equal x, the function are inverses, and this is using composition, which we spoke about earlier this unit. Okay, the directions say find the inverse of f of x equals 2x plus 4, and then I'm going to graph them both. So f of x is where I'm going to put the x, and where I have the x, I'm going to put a y, and now I need to resolve and get y alone. So I am going to subtract that 4 to both sides. So x minus 4 equals 2y. Now divide everything by 2. So y equals 1/2 x minus 2. It's a line, so this would definitely be a function. So we used function notation to show that this is an inverse. So now I'm going to go back and graph the original. F of x equals 2x plus 4. Remember, that means I start off at the 4 on the y-axis. I have a slope of 2, which is up 2 over 1. I can also go down 2 over 1. So there is the f of x. Now I'm going to go and graph its inverse. It says to start off at -2, and I have a slope of 1/2, which is up 1 over 2. And so this one is the inverse. And if I think about that line of reflection, remember that's going through here, and that would fold upon itself. So that is the inverse. So we have the equation of the inverse, and we've also graphed it. Okay, I have the function on the graph. It tells me to sketch its inverse. So I'm going to think about the original. This point right here is at -3, 0. This point up here on the y-axis is 0, 3. And this point over on the x-axis is 3, 0. Now when I'm doing an inverse, I just swap them. So 0, -3. Notice signs don't change. That's one of the biggest mistakes. And now I'm going to graph these of 0, -3, 3, 0, so it's on the same place, and 0, 3. And that is the inverse. So now they're going to ask me, is f of x a function? And yes, it was. The domain of the original went from -3 to 3. Notice the brackets because those are points on a graph. And the range was 0 to 3, also brackets because those are points on the graph. Now when I go and look at its inverse, because that f -1x means inverse, is it a function? No, because it doesn't pass the vertical line test. The domain would be 0, 3, and the range of this one would be -3 to 3. Now I want you to take note those switch. Take a note of that. Remember, we said earlier that the domain and range also switch. The x and the y coordinates, so this is x, this is y, and then I switch them, and that's why what was 0 as a y is now 0 as an x, and what was an x at 3 is now a y at 3. They switch places just like the domain and range. Okay, so now we have on this one, this is a square root function. So yes, it is a function. The domain goes from 0 to infinity, and the bracket around the 0 because that's a starting point. And then the range is from bottom to top, so the bottom is negative infinity to the top, which is 5. Now when I go write these ordered pairs, this point up on the y-axis is at 0, 5. And this point down below is at 1, 4. So now to do the inverse, this is going to be at 5, 0. And at 4, 1. And so 5, 0. And 4, 1. And now the domain, when I look at this, this is, yes, it's a function because it passes the vertical line test. The domain of this is going to be negative infinity to 5. Oops. Parentheses around that. And then the range is 0 to infinity. And I could double check I did it right because their domains and ranges swapped places. Okay, so now this says use compositions of functions to determine if the following functions are inverses. This is where we do f of g of x and then g of f of x. So I'm going to do f of g of x over here. So I'm going to take my f function and I am going to put in the g function in place of x. Now we're going to do the math. So 3 times 1/3 is x. 3 times 1/3 is 1 minus 1. My end result is x. So that tells me so far that way I have a function because my net result needs to be just x. Now this one is going to be g of f of x. So this time I'm going to start with my g function in place of the x. Put in my f function. Distribute, and 1/3 times 3x is 1x. 1/3 times negative 1 is negative 1/3 plus 1/3, and this net result is x. And now I can say they are inverses of each other. So this next one, do the same thing. I'm going to start off with f of g of x. So start off with my f function. I'm going to put in the g function. Distribute 3 times negative 1/3 is negative x. 3 times 1 is 3 plus 3. This net result is x plus 6. So not inverses. I don't even have to go and do the other side because if one side doesn't give me the result of x, the other side doesn't matter if it does or not. This is what proves me not a function. Okay, so the first thing I'm going to do is I'm going to graph this original function. This is a quadratic, so its vertex is at -2, -5. It has no reflection, compression, or stretch. So the pattern, you can use your calculator, remember, is 1, 1, and then 2. Over 2 up 4, over 3 up 9. And that's the original function. This is a quadratic, so So my domain is negative infinity to infinity, and my range is going to go from -5 to infinity. Now it says find the inverse. So this is the math we need to do. We're going to switch f of x and we're going to make that x equals y plus 2 squared minus 5. So now we're going to solve for y. So we're going to move that 5, add 5 to both sides, and get x plus 5. Now to drop this parentheses, I'm going to square root both sides. And if you go back to your algebra days, when we square root both sides, we can't forget the plus or minus. So x plus 5 is now under a radical, and that drops to get the y plus 2. Now I'm going to subtract that 2. So there's the inverse. Now the plus means it's going to have a no reflection and then a reflection. I can graph that if I know my square roots. That's definitely one way. The other way is I can come take these original points, which is at -2, 5, and then I have a -1, that's -5, sorry. -1, -4, and then -3, -4, and then I have 0, -1, and then 4, -1. That's enough for me to inverse. So now I'm going to go -5, -2, -4, -1, -4. Notice I'm keeping all the points with the same signs. I'm just switching the x and the y. So -5, -2, -4, -1, -4, -3, -1, 0, and -1, 4. So there's the inverse of the graph. The domain is going to be at -5 to infinity, and the range is going to be -infinity to infinity. Notice that the inverse is not a function. Okay, these directions say find the inverse and use composition to prove algebraically they are inverses. So first I've got to write this function. So I'm going to replace y with x and x with y. Now start solving. So I am going to subtract that 6. And I get x, sorry about that. I get x minus 6 equals -5y. Divide by -5, so I get -1/5 x plus 6/5 equals y. So now I'm going to use composition. So we're first going to start with the original of -5 times -1/5 x plus 6/5 plus 6. Distribute, and I get positive x, -6 plus 6, I get x. So in that direction, it definitely works. Now we start with the other, which is start with the inverse of -1/5, and then -5x plus 6. Where am I? Sorry. Plus 6/5. Distribute, and I get positive x, -6/5 plus 6/5, and I result is x. So yes, we can say that they are inverses of each other. Move this out of the way so I can do the next one. Okay, so now I'm going to do switch. In place of the y, I'm going to put an x. In place of the x, I'm going to put a y and resolve. Subtract that 4. Square root both sides. Don't forget your plus or minus. So there's the inverse. So now I'm going to start with the f function and put in plus or minus square root x minus 4 squared plus 4. When I square that, it drops the radical, so I get x minus 4 plus 4. So my result is x. So that one works that way. Now start with the inverse and put that in. And I am going to do plus or minus. And in place of x, I'm going to put x squared plus 4 minus 4. Then I am going to do x squared plus 4 minus 4 becomes x squared. And the square root of x squared is x. So my end result again is x. So I've just proved it algebraically.